Hello, this is OXDF, and today we're looking at the Advent of Code 2015, Day 18, like a GIF for your yard, and we're doing it in Rust, and we're doing it to learn Rust. Let's take a look at the challenge. Basically now I'm going to be given a 100 by 100 grid, and I'm going to have to animate this. And so the grid starts off with hash or pound sign being on and a dot being off, and then let's see, here we go. So we're going to do steps, and to go to the next step, a light which is on stays on if there's 2 or 3 neighbors on, and that's, looking all around. So here's A has 8 neighbors. B being on an edge, it's implied all these lights up here at the top are off, so it only has 5 neighbors to look at, and the other 3 are off. So if exactly 2 or 3 neighbors are on, it stays on, and if it's off and exactly 3 neighbors are on, it turns on. Otherwise, it stays off. So you'll have like an initial state like this, and we can start to look, like this one right here definitely goes off because there's no neighbors on, and so it turns off. This one right here actually has 3 neighbors on, and it's off, so it turns on, and that's why you get to this one here in step. So this is, if you didn't recognize it right away, it's kind of a famous computer science thing called Conways Game of Life. In fact, I'll show you real quick. I wasn't necessarily, I hadn't planned on doing this, but if you come here to the play Game of Life, there's like a simulator here, and you can start, and these are the rules for Game of Life, and you can hit start and watch these shapes move. But you can also make your own shapes. Like I like doing, you can do, a plus sign like this, and if you hit start, you can see how it goes, and it actually finds like a equilibrium here where it just stops and keeps going. But then you can do all sorts of neat things, like I have this plus sign. If you start another one right here, now if you hit start, they actually overlap with each other, and it goes from like, oh, it gets to stability pretty quickly to this whole range of things. And what's really cool is actually this one eventually goes completely away, which anyway, this Game of Life is really fun. You can waste a lot of time playing in this simulator, but see, now it's gone. So it's interesting how just changing 1 pixel here or there completely changes it. But anyway, that's not the point of this problem. I guess hypothetically we could throw our puzzle input into there and run 100 steps and see the results, but we're obviously going to do it in Rust, right? That's why we're doing it. The question is, how many lights are on after 100 steps? This was the first challenge I have not solved in Python, so I had to do this from scratch. But I realized I'm going to have to prep for these videos, and if I don't solve it ahead of time, you're going to watch me go. This probably took me, there's probably 30 minutes, 15, 20 minutes of me like fumbling around with dumb stuff that I don't think would be fun to watch. So I don't like just pull the code up and show it to you. Like I still go back and try to rewrite it, and I'm going to make mistakes, hopefully some of the same mistakes you can learn from the troubleshooting, but that way I don't get stuck for long periods of boringness at the same time. So I don't know, if you really want to see all that, leave me a comment and let me know, but I'm opting towards still trying to do them ahead of time. So at least for these harder ones, when Advent of Code comes out this year, and I might be back in Python, I'll probably do them live, at least for a while. Anyway, let's dive to VS Code. All right, I have this script I run called genday, which pulls down the input for me, so I can see my input.txt is just a big field, 100 by 100 of ons and offs, and I've got my nice starting point here. So I am going to, I'm definitely going to use a HashMap, so I'm going to go ahead and import that. Collections, HashMap. I'm not getting tab complete. We're going to stop real quick and fix the extension. All right, we're back, looking good. I'm going to go ahead and shrink this down too because I don't need it anymore. So we got our hash map imported. We're definitely going to do that. Let's go ahead and make a struct, and we'll call it lights. And let's see, I'll have a grid for sure. And because we're kind of fixed, well, sorry. So first, when I was tempted on my first run to make this a U size because of your grid, right? It's going to go like 0 to 100, or 0 to 99 because it was 100 wide. But then we are going to have to get outside of that. We're going to need the case where what happens when we try to get the neighbor of -1. Now maybe we write our code so we never try to check that. But I prefer to just write it and have, if it's if it doesn't exist, default back to being off. So I'm going to actually make these I sizes so that I can take a negative number if I need to. Again, there's no right or wrong answer here. The other thing we don't have to do, because I think we're sticking with a grid of 100 by 100, but we could, if we want to make this more comfortable for more flexible code, we can do we can record in our struct the size of the struct. So we'll go ahead and do that, make it look prettier. The next thing I want to do is I need to take all this input and I want to read it into a lights object. So I'm going to do impl, and I'm going to do something a little bit different. In the past, I've been doing like this from string like this for lights. And what I'm going to do, I was talking to Epi a little bit, and I guess it's actually preferred that you do from string when you're converting from strings specifically. Now, if you're converting from a vector, this doesn't apply. Use what I just did, but from strings, it's actually preferred to use the from string, and we'll have to use std, and it is in the. Ooh, let's see if I can remember this. Will it tell me? We need to delete this. Save. Give me an error here. Let's see. Standard string from string. There we go. I don't know why it won't just import that for me. I don't know. Probably some hotkey I'm just not aware of. From string. So now we got that. Okay, so now we have 4 from string from lights. And now we can do, now we're going to have to, there's a couple differences between this and the one I've typically done. The first one is that it allows for errors. The other one just, you can basically panic and that's it, versus this one can actually error and out and give you back results. Now for some toy example that we're doing here, that's probably not important, but when you get to more real examples that you probably want to know about this, the other big difference is instead of doing the into, we're going to parse. So I'll show that when we actually get to it. So, but it's still going to be the same idea. We're going to have a string object here. If I can type and talk at the same time. And we're going to return, in this case, because we can have errors, we're going to return a result. And it's going to either be a self or a self, I guess that's error, like that. There we go. So now we're going to return a result from a string. So we'll go ahead and say let mut lights equals self. The grid is going to be a hash map. New. The rows is going to be s.lines.count. So we're just going to get the number of lines, and that's the rows. Calls is going to be s.lines, and we're going to assume, for the sake of sanity, that all the lines have the same number of characters. So we can get the next one. We'll just get the first line. Dot unwrap. Dot chars. Dot count. So now we have the same thing. We're counting there, and that should give us that. Now we need to let's go over this grid and set everything how we want to set it. So we'll say for we r comma line in s.lines.enumerate. So that's, that'll give us that. Now we can do for c comma character, I guess we'll go with in line.chars.enumerate. All we want to do here, these errors drive me crazy. Let's come down here and we're going to return lights. We're not going to return it, so we're going to return OK lights. And that's, again, we haven't done that too much, but basically we're wrapping this in a result. And that way, if there was an error, we could handle it. But because because this structure returns a result, now we made a result object. Okay, so we're back here. What are we going to do? For each place, we're simply going to say lights.grid. We're going to get our grid dot insert. And if we look at our grid up here, it takes up 2 points. So we're going to say r as I size, because we need to make it the right thing. We'll get an error if we try to do it as a u size. C as I size, like that. And that's good. And now the value is going to be ch equals, and then character that. We need a semicolon at the end. Let's see how close we are. We might just be good. Okay, so what we're going to do is if the character equals, this is going to return either true or false, a boolean. Cool. And we're going to put it in at the RNC point in our grid. We will definitely need a semicolon here to close that off. I guess we don't need a semicolon after the for loop. And I think we're good there. Let's give it a try. So now we can build a lights object. So we have this. Let's come down here and we'll say, as our main function, we're just going to say, we're going to say, let mut, yeah, it has to be mut, lights equals data dot parse dot unwrap, like that. And see, it's probably gonna complain that it doesn't know what kind it needs to be. Yeah, it needs to be a type. So let's go ahead and make mut lights a lights. And now we've got a lights object. We can try to print it. We're definitely going to need debug print, and we're going to have to go derive debug on lights. But it's not hard. Let's see. We'll come here and we'll do derive debug. That. This might be just work. Cargo run. And look at that. We got a light object with all the pieces either being true or false, just like we want. So that looks cool. Okay, so now we need the ability to step through this. We'll come up here and we will impl lights, and we're going to say fn next, and we'll take self, and it's going to have to be a mutable self because we're literally going to update ourselves. And the first thing we're going to do is we're going to say let mut. This is always one of the challenges whenever you have challenges like this. You can't change self until you get to like every calculation for the next step has to happen on the current step. So we're going to make a new lights object, and it's going to. Oh, we don't even need a new lights object. We can just do a new hash map. Let's call it let mut next grid, and that is we'll have to define it as a hash map of. Takes I size, comma bool, and we'll say equals hash map new. Okay, so we've made a new grid. Now we'll do for r in 0 dot dot self dot rows, and then this again is going to return an a u size. So we'll do as I size to get it to the right thing. Then we can do for, I don't know why I said I. Let's stick with R. For R in there, and we can do C in 0 dot dot self dot rows, dot calls as I size. So now we're going to loop through our whole thing. I'm sure this could be done with chaining and pipelining. I can't quite figure this one out yet. So I've been playing a lot with that lately. I've actually got been working on the day 15 one. I think it was day 15, trying to get that pipelined, and I'm going to have a video for that, I think. But anyway. We're going to stick with this for now. So we've got this here. What are we going to do? We're going to say, so for each one, let's be really verbose about this and make lots of variables. We could probably streamline it down, but let's make it readable. So for current, let current equal self.grid.get r comma c, like that, dot unwrap. See if that works. So we have a bool. That's what we want, a bool. Okay. What is this? Expected a pointer, so we'll put a pointer there, and all right, we got a bool. It's a pointer to a bool. I wonder if we can get rid of that, if we can dereference that. No, we got a bool. Sweet, that's exactly what we wanted. Okay, so now we'll do let num neighbors equals self dot count. We're gonna have to make a function here, neighbors, and that will take an r and a c. I think that's enough. Since we haven't made that function, it's certainly going to error when I save this, but okay. Now we can say let next equals, so for this point, it's going to be next if, we'll have to kind of make a bool here, but we'll say if it's current, so if it's currently on, and now we can say 2, 3 contains num neighbors. Is that gonna, no, you're not gonna give me that. GIH now you give it to me. Okay. So if 2 or 3 contains neighbors, so if neighbors is 2 or 3 and it's current, we're good. We're gonna stay on. That'll be a bool. Or now we can put another one. We can say maybe we'll go to the next line on this. Oops. Let's see if we can close this off. Now we can say or, and we don't need either of those. We need a new line. Now, if so, it's not. So we can say or if it's not current, and num neighbors equals 3. So the next for that spot will be this bool right here. And we're not happy about it. What do I like? Can't compare an integer with an integer. Do we just put a pointer in front of that? All right, so we're still complaining we don't have to count neighbors, but that's fine. We can do that. Let's finish this off and then we'll go make that. So now we can just do next grid dot insert. Our spot will be r comma c in there, and our value will be next. Like that. Don't you like about this? Oh, let's get rid of that. There we go. Sweet. And so now we're going to loop through all of these and we're going to make this whole next grid. And then whenever that's finished, before we're done, we will say self.grid equals next grid. Oops. Next grid. Cool. So I'm not getting yelled at all except for count neighbors doesn't exist, which we expect. So let's make that. So now we can come here and say fn count neighbors. We're going to take self. Doesn't need to be mutable for this one because we're just going to count. R, which will be an I size. And C, which will be an I size. Whoa. Sweet. And it will return a U size. We just need a number. And so what we're going to do is we're going to say let mute num on equals 0. And we're going to do for dr in -1 dot dot 2, because that'll give us -1, 0, and 1. And we do for dc in -1 dot dot 2. And now we're going to say, we can say if dr equals 0 and dc equals 0, continue. So we don't want that. Like we don't want to count that one. We don't count ourselves. Because that's that. And then we can say, I guess we just need to get self.grid.get the tuple. So that'll be r plus dr, c plus dc. Does that work? Ooh, let's see. We want to get that, and we want to say if that num on plus equals 1. And down here okay, so we're getting yelled at because we're not returning anything. So we're going to return num on. Okay, so now we're clearly junked up here. Okay, so expected type bool, it got an option bool, so we got to unwrap. Okay, that's expected. What do we got now? Consider borrowing here. Okay, same as we did above. Probably could have just copied that line. Expected a bool, found a pointer to a bool, so we will dereference it like that. And ooh, no more errors. So, oh wait, num neighbors is off here. Let's see. Expected integer found U size. Maybe we need to put a pointer here. And what is this? Consider removing the borrow. Okay, you told me to add it earlier, but we can take it away. Cool. So now let's try to run this. Where's our main here? So we can come down here and we can say, if we say lights.next, do we run and do we get any errors? We do. At 31, oh, okay, cool. This 31. So we made this 31. I talked about it already, but I didn't do it. So when we have this pointer right here and we get our, so if the point is 0, 0 and the dr, dc are -1, we're going to read outside of our grid where we haven't set yet. There's a couple ways we could fix this. One, we could go up here in our creation or down here in our creation and go through and say, you know, for all the things in the negatives, just set them to false. Or that we can do is actually kind of do an unwrap or, and now we can say false. So basically, if it fails, just make it false. I think. Consider borrowing here. A pointer to false. Okay. Don't understand why, but we're going to go with it. So now if we run this and we get a grid. Now, I can't say this is right, but let's pretend it's right. If it doesn't end up right, we'll certainly go to and troubleshoot. We don't want to do like, I guess I could come down here and do like lights.next 100 times. But that's a pain in the butt, right? So let's come here and we'll do function, and we'll call it like run steps. It's going to take a mutable self, and it's going to take a num, like num steps maybe, of u size. And it's not going to return anything because we're just going to modify ourselves. And we can say for I in 0 dot dot num steps. And now we're just going to do self dot next. Like that. And it's going to yell at me. It doesn't like that we're not using I, so let's get rid of that and put an underscore there. That means we're throwing it away. And now, instead of coming down here, instead of doing next, we can do run steps 100. Now, we'll give this a try. Where do we import num? See, why is it that I can't get the from string to import, but like the num just imports on me all the time? Anyway, let's. So we ran and we got a thing. I guess now we need the ability to count the number of trues. So we need another function. Coming down here and we do function count on take self, doesn't need to be mutable. It's going to return a u size because it's going to be a positive number. And so we can do self.grid. And let's just do a pipeline here. This one we can do. We can do values. That'll give us all the trues and falses. And now we can do a filter. And we will take some Boolean value. And literally we just need that Boolean value. And then we can count. Because that Boolean value is either going to be true or false. Let's see. So we don't like that. We don't need the semicolon there because we're returning the whole thing. And we still don't like that. What do I like? HashMap is I size, U size. I don't remember a 4. I think I put this in the wrong place. I definitely put this in the wrong place. Let's get this off here. Doesn't belong. I had put it down here in this from string. It belongs in with the lights functions. Ooh, too much space. Okay, let's try that again. Okay, we don't like the B. Consider dereferencing the borrow. Okay, so we expected a bool and we got a pointer to a bool. So we will dereference it twice. And we seem happy. So now, come down here, we can do lights.count. And we don't have no semicolon. And we can run this. And we should definitely be running it in release mode. See how long that was? Let's just see real quick. It's gonna take a second. Yeah, that was way faster. 1061, that's the right answer, I believe. I did want to show real quick before I go to part 2. Let's say it was the wrong answer. Like we made a mistake, because I actually did make a mistake when I was doing this originally. The way I troubleshot was in my next function. Like I thought the problem was clearly how I was doing the next function, right? So I wanted to test that. And what I did was I came down here and said, let's just say like if r equals 0. I don't need this. I don't want the whole thing. But let's just do print line, and we'll say like, let's see. I'll do r comma c, and then close that, and then I want to get like current num neighbors and next. That seems like a good. So now for the first row, so the first 100, in fact, we could probably say like r equals c, and in fact, let's do this. Let's say and c is less than 15. So for the first 15 things, we're going to print. And what we get here is now we can look at this and say like, ooh, what's going on here? And I thought, it's in the next function, because we're just running the first time. So it looks like over time, it's like, then that's the other thing let's do. Let's go down here now, because we want to investigate this. We're going to run down here and do, we're not going to do lights. We're not going to run this 100 times. We're going to do lights dot next. Let's do lights dot next. Now we're just going to run it once, and let's see what it looks like. And we get here is, okay, we can see it. And so let's go back to our input and we can like literally look at this first one and do it manually. Okay, the very first top left one, it's got one neighbor on, it's gonna go off. So we can see it was true. It has one neighbor, so num neighbors is working correctly there and it goes to false, great. This next one, it looks like it has two neighbors on and it's off, so it's gonna stay false, okay. The third one looks like it is false and it's got two neighbors on, so it's gonna stay false. It looks like it's working. This next one is on and it's got two neighbors on, so that should stay on. So yeah, it does. And so I can start to work through here. And what I found very quickly, it was right in the first row, I was like making mistakes here and there. I was misreading how I was doing things. So I was able to quickly say, oh, let me figure out what's wrong and like fix that. So a couple little print statements here and there will do very nice work for you. Anyway, we'll go back. We don't need that anymore, but I will leave that in. The other thing we could do that if this didn't work was, we could try making smaller grids and use some of the example input, and B, we could make a print grid function so that we could print the grids and see how they're evolving over time and see if they look, and do some manual investigation and see how they look. Okay, let's jump over to part 2. The point of this is all wrong. It is Game of Life, good. Until you notice something's wrong with the grids, the 4 lights in each corner are stuck on and can't be turned off. They actually look like this. And that's the only change. So let's go back and we can say, I think the way I would want to do this, because you could just go and change this tinker with this and just do your part 1, be done with part 1. I like to have like my OCD. I want to have the result that prints part 1 and part 2 in one run. So we're going to do that. And the way we're going to do that is for our next function here, we're going to add a thing. So we're going to call it like part2 bool. And then when we call next, which is really from run steps, we're going to have to say next. Well, actually, let's not even do it in next. We'll do it in part2. We'll do it in run steps. So we'll come down here and we'll say, run steps can take a p2 bool. We'll need to come down here for where we call that and say run steps false. Now, what we'll do is we'll say at the very front, at the very beginning, we'll have to say if p2 self dot corners on. We'll make it, we haven't made this function yet, but we will. So if we're going to make sure the corners are on in our input, I'm not sure if they are or not, but that'll be fine. And then each time after we call next, we'll say if p2 self dot corners on. That. And now that's it. So basically, before it runs, we'll turn the corners on, and after each run, we'll turn the corners on, and then we'll be good. So now we just need to write corners on. So function corners on, going to take self, a mutable self. That's it. We just need to, because we don't need anything fancy. And we can just do, we'll do 0, 0, comma, we can just manually do this. 0, self dot calls -1, self dot rows -1, 0, and self dot rows -1, self dot calls -1. Those are the 4 corners. And then we can just turn that into an iterator. And then we can say for each, go to the next line for this, and we'll say, so there's gonna be a point p, and for that p, we're gonna say self, I don't even know if we need the brackets, self dot grid dot insert p comma true. So effectively, we're going to say for each of these 4 places, we're going to turn them on. We need a semicolon there, I believe, and it doesn't like this. What don't we like about this? Expected type blank found in option bool. Maybe we put a semicolon there. P is a U size. Don't we like about that? I'm surprised. Let's see. Okay, so so we iterate over those. Get a P, U size. Do we need to make this a pointer then? Statement found outside a block. Oh, okay, maybe we need to put this in a block. Maybe I was wrong about that. Let's put that here, and we will put this here. We'll save this. Ooh, now we have at least a better error. We at least have an error. Expected type found a bool. Put a thing there. Maybe that's the problem. Okay, we're making some progress. Consider removing the borrow. Expected a format. Okay, so between some I don't think that interesting troubleshooting and some loud screaming from the children in my house, I'm gonna go ahead and I'm gonna shorten down a bunch of that stuff. But the short answer here is what I was doing, what was wrong and what wasn't working here is, one, this shouldn't have been a pointer. This should have been a dereference, not a reference. But also, these are returning U sizes. And I need I sizes to go into the thing. And it was really getting confused and struggling with that. So this seems to work. We will get rid of this. And basically, that's going to turn our corners on. So let's give this a run. Oh, so we didn't. So, okay, so what? If we come down here now we can do for part 2, we can say lights2 equals, let's actually make it lights2, let mut lights2 of lights equals data.parse unwrap. And now we will do lights2.run steps 100 comma true, like that. Now we're running them with the light, the corner's always on, and we can do lights2.count on. And if this works, we're going to run the whole thing twice effectively, but that's okay. And we get 1006, which is the answer. So I hope this is enjoyable. This one was trickier, but it wasn't that complicated. But it just, if you have any errors, there was a lot of work to troubleshoot it. So with that, I'm going to call it here. Thank you so much for sticking around till the end, and I'll talk to you next time. Bye.